for introduction purposes, I'll introduce myself. My name is Penina Musangi, and I'll be taking you this course that is the Information Communication Technology. And first, it is good to go through the course outline, which I want to share so that we can see what we are going to cover in this course. Can you see can you see my screen?
The slides now.
Yes, we can see.
Yes,
No,
we can
it is
see.
not a slide. It is a Microsoft Word document, the course outline.
Yes,
Can
it's
you
there now.
Yes, we can
Yes.
see.
Yes, we can see.
Oh, okay. So this is the course outline. Please mute. You don't unmute if you are responding. So it is important for us to mute. And also for clarity, it is important for us to also mute the camera. That makes the network strong, and also it makes the recording clear, better in terms of clarity. So this is the course outline of the course we are going to have. The course is titled Information Communication Technology, or ICT, and it is coded AIU 113. It is a 3-credit hour. What it means is that we are supposed to be taking 3 hours per week. But if it is face-to-face lecture, but now that it is distance learning, we are going to see how to cover it. But in terms of we are going to see to cover the full course. If the scenario, the pandemic ends, we'll have a face-to-face session. Especially, we are supposed to have some practicals. But I'll see if it's not possible. I'll see how to engage you in the practical. You can do it, and maybe you present. I see whether you get what the aspect, practical aspect, which I want, which is to be achieved in this course. So we start with the purpose of the course, and it aims at preparing you as a student with the skills for the application of ICT during training. So you use the ICT in training. During your professional practice, as you practice, you're supposed to apply ICT, so you have the skills, and in research and learning. So how do you apply ICT in those areas? Training, professional practice, research, and learning. What are the expected learning outcomes? At the end of this course, you are supposed to have basic computer skills. You are supposed to describe various application softwares for research and for practice. What applications can you use in your work? What applications can you use for research? Then also you are supposed to appraise the role of ICT in your professional practice. What is the role? What role does ICT play in your professional practice? Then you are also supposed to describe the challenges in the adoption and use of ICT. So what challenges are there in the adoption and use of ICT? And whenever we discuss challenges, it's also good to brainstorm about the solutions and even the way forward in terms of these challenges, because it is not good just to know about the challenges and that is the end of it. We also look at what are the possible solutions or way forward in terms of the challenges in adopting and using ICT. So those are the course objectives. So what are we going to cover? What is meant by course content? We are going to look at introduction to ICT, which you are starting today. And introduction to ICT will cover the history of computer, introduction to computer hardware, software, all the way to operating systems. The second major topic will be introduction to computer applications, which will look at all these applications. And these are the ones whereby we are supposed to have practical or hands-on practice. Then another major topic will be the role of ICT in the professional practice. So how do you use ICT in your work environment in carrying out your tasks? How do you use it to improve efficiency and effectiveness? What is the role of ICT in health, telemedicine, the challenges of communication media, the influence of ICT, and work ethics and productivity? And the last topic, major topic, will be the challenges in the adoption and use of ICT, where we look at challenges like investment, security, sustainability, and compliance. So those are the 4 major topics we are going to cover, but with several subtopics. Then I'll not talk about the mode of delivery because this has been modified because of the COVID. Then in terms of assessment, we are supposed to have 2 continuous assessment tests, which will contribute to 30% of your final mark. Then we have a final trimester exam, which contributes to 70% of your total mark. We are going, as we go along, we'll discuss how we are going to have the continuous assessment test, because the end of trimester exam, that one will be later after this pandemic. In terms of the core reading materials, this one will I'll be giving reading materials every topic. Once we cover every topic, I'll be having a slide on electronic further reading materials you can consult further to beef up your understanding of what we have covered in class. So basically, this was meant if it was a face-to-face class. So that majorly is the course outline and what we are going to cover in this course. So any comment about the course outline? I hope you are together.
Yes, we are.
Perfect. So straight away, let's now go to our first topic. You can see my slides.
Yes.
Yeah,
we can see them.
Yeah, we can see them.
Oh, okay. So still under introduction, this is a university common course. And what we mean by a university common course, it's a course taken by all undergraduate students in the university. And that's the reason it has really taken us long to agree on what time we are going to have this class. So in this class, I'm having a Bachelor of Nursing students, I'm having Bachelor of Midwifery students, I'm having Bachelor of Science Community Health Practice, and I'm having class of Bachelor of Science in Physiotherapy. Yes, I'm having 4 groups. So that is the reason it took long for us to agree on what time we are going to have this class. And as I explained, we are going to be having this class on Friday, as I requested, on Fridays 8 to 11, 3 hours if we have the energy. So, and it will be offered through Microsoft Teams. For the benefit of those students who will not make it for the class, we'll be recording the lectures and I'll be sharing them with the same class. So for reference, for those who are in the class, they will refer back. And also for those who did not make it for the class, they'll be having an opportunity to listen to our discussion. So these are university common course. And what is the objective? I had explained the objective of the course. That is, we need to understand ICT, have the knowledge, enhance our knowledge, our skills, and our competencies in this era of ICT, and also understand how it affects our daily operations and our in our work, the evolution of technology. Technology has really evolved. So it is for us at this time to look back and see where technology has come from. So that is the reason why, one of the reasons why we need to we need to study the history of computers. The second reason why we study the history of computers is also to appreciate and acknowledge the people behind that evolution. We are saying that technology has evolved, but this technology which has evolved, there are people behind that evolvement. So who are these people? We need to understand them, appreciate them, and acknowledge. So those are the two major reasons why we are going to study the history of computers. These are in this history of computers, we are going to cover 4 subtopics. Hello? Okay, 4 subtopics. And our first major topic, subtopic will be defining a computer. We are going to describe the first computers or first forms of computers, look at the history of computers and categorize those computers into generations. The objective of this particular topic is to develop a familiarity with the history of the personal computer, describe the earliest forms of computer, highlight the major milestones in the development of modern computers and internet, and also list the names of the people responsible for development of computer and the related technologies. So those are the objectives by the end of this topic, which I believe we are going to cover today. We should be able to do all the 4 things. So we start by defining a computer. I request we mute somebody. There's some noise coming. So let us mute. Let us mute. You only unmute if you are talking. So let's define a computer, and there are various ways we can define a computer. And the first way is a computer being a programmable machine. What we mean by a programmable machine is a machine that can be instructed what to do. To program is to instruct a device or a machine on what to do. So that is how we can define one way we can define a computer as a programmable machine. The second definition is a machine that manipulates data according to a list of instructions. So manipulated data is changing, controlling, using, or handling data. So you feed or you provide data to a machine, and it changes that data, it controls or it uses that data following a list of instructions. So that machine now can be termed to be a computer. So that's another way of defining a computer. And the last definition which I've provided for you is that it is any device that aids human in performing various kinds of computations and calculations. So any device that helps you as a human being to compute, to calculate, then we can also term it as a computer. So a question may pop in your mind. We use a calculator to calculate, and it helps us to calculate. Is it a computer? We use our phones. It has that application of calculations in terms of it has a calculator. Does that mean it's a computer? We are going to answer that question. So that's how we can define a computer. Moving on, in defining a computer, 3 principal characteristics of a computer emanate or they present themselves. One, we are seeing that when we are defining a computer, we are seeing it is a device which responds to a specific set of instructions in a well-defined manner. So this machine or this device is responding to a set of instructions. And in responding to that set of instructions, it is doing that in a well-defined.
Teacher, are you mute? Hello, teacher, are you mute?
Sorry, you can't hear me? Hello?
No. Now I can hear. Now we can hear.
We can hear you now.
Oh, sorry. So where did I lose you? At what point?
Where you are defining about computers after that.
And did I started discussing the characteristics?
Yeah. Yes, the
principles.
the first principle
Yeah, the
characteristic.
principles. Okay, fine. We are still there. I can go back a few steps. So I was saying, when you are defining a computer, three principal characteristics emanate. So one, we are saying is that it responds to a specific set of instructions, and in responding to that instructions, it does so in a well-structured manner, or what we call a well-defined manner. So it is not haphazard. The other characteristic is that it executes or it implements that list of instructions which has already been pre-recorded. So the list of instructions is already defined prior. So it is not, the instructions are not defined now. The instructions are executed which have already been defined prior. And the last one is that it has this capability of quickly storing and retrieving large amounts of data. So those are the three major characteristics which present themselves when you are defining a computer. The ability to respond to a set of instructions in a well-defined manner, executing an already pre-recorded list of instructions, and the ability to quickly store and retrieve large amounts of data. So moving on, we have now let's look at the earliest forms of computers. And originally, actually, calculations were computed or were done by human beings, and these humans were the ones who were assigned the job title computers. So the use of the word computer, actually it meant compute. And when you are employed and your work involved computations, your job title was computer. And that is the original use of the word computer. So these human computers were typically engaged in the calculation of mathematical expressions. So those people were mainly doing calculations. And for you to qualify to become a computer, which was a job title, it required a period of specialized and expensive training in mathematics. So you had to be trained in mathematics, and when you qualify from that specialized training, now your job title, you assigned, your work is to compute or to calculate, and your job title is computer. So the first use of the word computer was recorded in the year 1613. So it's not a new terminology, and we are saying it referred to a person who carried out calculations or computations. So the first computers, we can say they were people. The first computers, we can say they were people, and this was a job title. A minute, please, a minute. So the first, let's continue. The first computers, we can say they were people, and this was a job title given to people who did repetitive calculations. But we have the term personal computer, and the term personal computer was introduced in the year 1973, and this was a development of technology which made computer more accessible to individuals. So when we say personal computer, the term computer being personal came into being this time because now computers as machines, as devices, were more accessible to individuals. They could afford and they could buy personal, as they could afford. So that meant people could own computers, and therefore there came this term personal computer. Before this time, 1975, computers were very large and they were very expensive, and they were majorly solely owned and operated by big companies. So you could not find persons owning computers, and therefore it was generally known as computers because they were only for big companies. But when the time came that computers could be afforded by human beings, that they could buy, they could own, then now the word personal computers was introduced.
Hello, Malim.
Yes.
Yeah, you just mentioned 1973, but from the
75.
slides, yes,
Oh,
from
sorry.
the slide, yeah.
It is 1975, sorry.
Okay, thank you.
Good. Thanks for that clarification. Then, what are the earliest forms of computers? As we have seen from the introduction, is that computers was any machine which could help people calculate. And therefore, any instrument, any device which assisted a human being to compute, to calculate, could be termed as a form of a computer. And we can trace this back to the use of tally sticks. Tally sticks was an ancient memory aid device, and this device was used to record and document numbers, quantities, and even messages. And therefore, we can term it as a form of an early form of as a form of a computer, because it was a device to help human beings to document numbers, to calculate, to record. So tally sticks. Then we also have another form of early computers, and that was the abacus. And the abacus is a calculator, and it was first recorded in the year 1500, and it is actually a Chinese invention, and they invented it to help them to add, to subtract, to divide, and even to multiply. And what we are seeing from these uses is that it was being used to calculate or to compute, and therefore we can say it's also an early form of a computer. We also have the analytical engine, and the analytical engine was the first mechanical computer. The first two were actually so much manual, but the analytical engine now brought in the first mechanical computer, and it was developed by Charles Babbage in the years 1922 and 1971, and it was designed to receive instructions. Remember, in definition, we said that device has to receive receiving instructions from a punched card. What we mean by a punched card, that a card was punched the way we punch using the paper punch, but the hole which comes in is the one which contains the instruction. So that this machine was receiving the instructions which were already in those punched cards, and actually the work of that the instruction which were there was just to make calculations. And you can see they are all doing calculations and computations. Another early form of computer was the slide, and it was based on what we call the Napier's logarithms. And what they used it for was about primarily multiplication, division, and roots, logarithms, and trigonometry. But one shortcoming with it is that it could not do helping the people who are using it to do some aspects of mathematics. Then moving on, we had the stepped recorder. Stepped recorder was invented by Gottfried, and it was also a machine which could add, subtract, multiply, and divide. But one good thing with it, it could do this automatically. So the addition, the subtraction could be done automatically. We had the Jacquard loom, also another form of early computer, and this was a mechanical loom. A loom is used in the cloth industry to design, to weave fabrics. So Jacquard, Josemarie Jacquard, in the year 1881, he invented this Jacquard loom. And the Jacquard loom was also a calculator or a computer to compute how the design will be weaved. And it was automatic. The weaving was automatic, and it was automatic, being controlled by a punched card, which I've explained how a punched card used to work. Then we had the arithmometer. Arithmometer was a mechanical calculator now, and it was invented by Colmer. And we say it was the first reliable, useful, and commercially successful calculating machine. So what we mean by commercially now is that it could be sold, it could be mass produced. And once it is mass produced, is that it could now be sold to those people who wanted to buy that calculating machine. Then we had the tabulating machine. The tabulating machine was invented by Hamann in 1890, and basically this was to assist in summarizing information and accounting, and it was used for census. Actually, this guy Hamann, some history is that he was working with the U.S. Census Bureau of Statistics, and working with them in the year 1880 when they carried the census of that year. It took 10 more years to calculate the statistics, to release the data. And this guy, because we say necessity is the mother of invention, this guy thought that it was necessary to invent something which would assist them to shorten the time to release or to calculate the data, the census data. And therefore, that necessity led him to invent the tabulating machine. And the tabulating machine is now, which was later used in the census of 1890 after, and it really helped. We are going to see how it helped. So that is, those are some of the early forms of computer. You could see some aspects of all those machines were to assist human beings in doing some tasks, majorly in the calculations and all that. So with that, we can look at the brief timelines in terms of history. We look at the timelines, what came at what time and who was behind that. So in the year 1801, that is the year Marie invented the loom, the jacquard loom I was talking about, and it was used to automatically weave fabric designs, and it used the punched cards. 1822, Babbage came up with a calculating machine that was used to compute tables of numbers. 1890, Hamann, which I was talking about, designed a punch card system and the tabulating machine, which was used to calculate the 1890 census. And when he accomplished that, actually the 1890 census took 3 years. The previous one I've said it took 10 years. So this one for 1890 helped them that it took 3 years, and it saved the government $5 million US. And this guy is later is the one who established what we know today as IBM. IBM, you know, it's a trend setter in the ICT world. So this guy, after coming up with the tabulating machine, he later on advanced his technology, and is now the one who came to invent or to establish that company called IBM. 1936, we had Alan Turing. Alan Turing was came up with a universal machine, which he later called it Turing machine. And this machine was capable of computing anything that is computable. At this point, what this machine brought into the ICT world is that previously it was only calculation, additions, subtraction, those mathematical expressions. But there are more than that computations. You can compute even an algorithms and many other things, so, which could not be done previously. But when Turing machine was invented, it was now possible to compute anything which is computable. And that idea of a computer being able to do anything, almost everything, is now the central concept of the modern computer. Actually, the modern computer basis is the idea of the ability of being able to do most of the things from this gentleman called Alan Turing. 1937, Atanasov was a professor of physics and mathematics at Iowa State University. He attempted now to build the first computer without gears, cams, belts, or shafts. Remember the previous computers we were talking about them being mechanical, and you know something which is mechanical, it is driven by gears, cams, belts, and all that. So 1937, now this professor now attempts to build a computer without now the mechanical aspect, the mechanics of it, that is the gears and all that. 1939, the HP, what we know today, was founded by David and Bill. And you can see actually they got the name HP, Hewlett Packard, comes from their two surnames, Packard and Hewlett. So they founded that brand of HP, what we know of it today. 1941, the professor, the one who attempted to build a computer without gears, was supervising some students, PhD students in that university. And therefore, with one of his students called Clifford Berry, they designed a computer which could solve 29 equations simultaneously. One thing you'll note that previous computers before this, they were solving one problem at a time. That is, you issue one instruction until it is finished is when you can issue another instruction. So it was they did one instruction at a time, but this time now Atanasov and Berry, they designed a computer which could compute or could solve 29 equations or calculations simultaneously. Now try to solve that issue of one problem at a time. And with that, it marked the first time a computer was able to store information in its main memory. So for the computer to be able to compute this number of instructions, it means they have to be stored somewhere in a memory. And therefore, this is the time now memory came to be used. So like today, we are using computer and we can do many things at a time. So what enables that ability of a computer to do several instructions, to carry out several tasks at a time, is the memory, because all those instructions will be stored in the memory, and that's where they'll be fetched to be executed. 1943 to 1944, other two university professors from the University of Pennsylvania, Markley and Presper, they build what we call electronic numerical integrator and calculator, abbreviated as ENIAC. Actually, when you ask many people, they'll tell you the first computer was ENIAC. You hear that in most of the literature, that the first computer was ENIAC. But there is a lot even before, a lot happened even before ENIAC came into being. So what is known is that ENIAC is actually the grandfather of computers. And it is not just computers, but digital computer. The previous computers were mechanical, but now ENIAC ushered in the era of digital computers. However, it was a very huge computer which could fill a 20 by 40 foot room. So it meant that for you to get it, you needed to set aside such a room where it could be fitted. And it used 18,000 vacuum tubes for circuitry to provide power across all the parts in the computer. In that computer, it used vacuum tubes. 1946, these two gentlemen, now they left the University of Pennsylvania, and they were funded by the Census Bureau to build the second computer, which was called UNIVAC. And when they built it, this now ushered the time computers could be sold to businesses and to governments. So computers now started being bought by institutions, government and businesses for use. So UNIVAC was the first computer to be made so that it can be applied in commercial and business and even government applications. And this was done by these two gentlemen. 1956, a lady by the name Grace developed the first computer language. Remember, when you're looking at what I said, when you're looking at the brief timelines of the computer, it is the computer and the related technologies which go together with the computer. And one of them is the computer language. And the first computer language was called COBOL, and it was developed in the year 1953 by Grace Hopper. 1954, the first programming language was Fortran. Fortran is an acronym for Formula Translation. And this one was developed by a team of programmers who were working at IBM. 1964, Douglas showed a prototype of a modern computer. A prototype is a model of how a modern computer would look like if it had a mouse and it had a graphical user interface. So Douglas came up with a model of how a computer would look like if it had a mouse and a user interface which had icons, it has menus and all that. And actually this marked the evolution of computer from being a specialized machine to a machine which could be accessible to the general public. Initially, before Douglas now brought in the idea of using a mouse and having a graphical user interface, computers were mainly specialized and they were only used by scientists and mathematicians because they were using them to compute any computable idea. But now when Douglas brought in the model of having a graphical user interface, it was now possible for a computer to be used by a non-scientist, by a non-mathematician. So technology was now more accessible to other people, to the general public, other than the scientists and the mathematicians, because how to navigate, it was possible to easily know how to navigate because of the graphical user interface. 1969, a group of developers who were working at Bell Labs produced the first operating system, and the first operating system was Unix. And one thing to note about Unix is that it was an operating system which addressed what we call compatibility issues. Previously, computers, the hardware had to come with the software, with the operating systems and everything from the same manufacturer. So you could not buy a computer and get the operating system from another vendor. You had to get them from the same one. But now, when this group of developers developed Unix, Unix solved the issue of compatibility. It was possible for Unix to be installed or to be used in any machine, in any computer. So you could buy your computer from another vendor and you get Unix and you are okay, you can work with it. So it was at this point when Unix came into being and it addressed what we call compatibility issues. 1971, a major development came in from a team a team led by Alan, who were working at IBM, and they invented what we used to know as floppy disks. Floppy disks were not there, and therefore a computer could only store data on itself. So it was not possible to share data from one computer to another. But when the invention of floppy disk was done in 1971, it was now possible to share data from one computer to another by use of a floppy disk. And when you talk about the floppy disk, it's not only the removable, but even the port where the floppy disk was to be inserted was a development from these IBM engineers. So that was done in 1971. 1973, Robert developed Ethernet. Ethernet was developed in the year 1973, and with the internet, this allowed multiple computers to be connected, and also to connect computers with hardware. So Ethernet enabled computers to communicate. So one computer to communicate with another one, a computer to communicate with another hardware like printer, and therefore you could print. So this is the time that came into being. 1974 to 77, now personal computers. Remember how I defined or I described personal computers. We have been talking about computers. Now this time, 1974, 77, now personal computers came into the market, with some including Shelby, Mark 8, Altair, IBM, and all that. So personal computers were in the market. They could be bought by people. 1975, Paul Allen and Bill Gates, they offered to write software for a computer, for a personal computer, which has come in the market in 1974, Altair. And they used a new basic language, and they succeeded. They succeeded in writing software for Altair, that type of a computer. And later on, these are the two friends who later on formed the company we know of today as Microsoft. You know, people today know Microsoft as owned by Bill Gates, but actually it's a company which was owned by Paul Allen and Bill Gates, and they started their friendship from this time when they wrote these software for that computer. 1976, Steve Jobs and another Steve, they started what we know as Apple computers, which later on came to, they are the ones who have produced the iPhones. So Apple computers was an invention of Steve Jobs and Steve Wozniak, and they did their first computer, Apple I, with a single circuit board. 1983, the Apple, they did another version of computer called Apple Lisa, and Apple Lisa was the first personal computer. Now, personal computer, not computer, with a graphical user interface, and it had features like drop-down menus, icons, and all that. But later on, that invention did not succeed. It flopped. But eventually, they continued working on it, and it evolved to become what we used to know as Macintosh. Apple Lisa now came to be known as Macintosh. 1985, Microsoft now announced their own operating system, Windows. Remember, we had said the first operating system was Unix, and Unix was for computers. But now, with the coming on of personal computers, it was important to come up with different operating systems. In 1985, Microsoft, which was now in place, they produced their operating system, that is Windows. 1985, the first .com domain name was registered, what we call .com. Now internet is coming to be in 1985. So that is the first time a .com domain was registered. 1990, Tim Berners-Lee developed what we call as hypertext markup language, HTML, was developed in the year 1990. And the development of this language now is the one which gave rise to now the World Wide Web, WWW, was enabled by the use of this language called HTML, which was developed by Tim Berners-Lee. 1996, Sergey and Larry Page developed what we know as Google search engine. So Google search engine was developed in the year 1996 by Sergey Brin and Larry Page. 1999, just the other day, now Wi-Fi is when it came into being. And now Wi-Fi, or what we call wireless. Now wireless, now it gave an opportunity for computers to connect to the internet without necessarily using wires. Before, they were connected using the Ethernet, which we saw previously. But now, 1999, it was possible to have a connection to the internet without wires, and that is what we call as Wi-Fi or wireless. 2007, iPhone brought in a major milestone which changed now the phone industry, and that is it brought the computer functions into smartphone. So iPhone was the first actually phone to bring computer functions to be done by a phone. And you know that using a phone you can do majorly, and you can majorly do what a computer does. I know some of you are using your phones, smartphones, to connect to these. I'm using my laptop. and other people are using their laptops. So see, that shows that what a computer can do, a smartphone can do. And this started in the year 2007 when iPhone brought computer functions to the smartphone. So that is now the brief timeline which I could highlight about the development of the computer, personal computer, and even the related technologies in terms of software, in terms of Ethernet, internet, and many other things, related technologies, which we can see that we can see their history and how they came into being, and even the people behind them. So with that history, I want now to group that history into generations. Unless you have a question, it is, as I said, you can always unmute and you ask your question, and I'll be able to respond. Okay. So we now see the computer. We group the many forms of computers we have talked about into generations, and we can group them into 5 generations. There is the first, second, third, fourth, and 5th. We are going to look at each in detail. So we start with the first generation, and we can say that the first computers, all along, the first computers we have been talking about, they used vacuum tubes, and they fall under the first generation. So they were using vacuum tubes for circuitry, and they were using magnetic drums for memory. And these computers were majorly enormous or big in size, taking up an entire one. The area we said it could fill in a 20 by 40 foot container, or not container but room, meaning that it was really huge. In addition, they were very expensive to operate and even to acquire, and they were also using a great deal of electricity. So to power such a computer, it used large quantities of electricity. And because of that, they generated a lot of heat. And this heat led to causes of malfunctions because of overheating. So they were, most of the times they were malfunctioning because of the overheating, which was caused by we are saying that they were using a great deal of electricity. The first generation computers relied on machine language, which is the lowest programming language, and it was purely understood by computers. So they could not understand our human language. I'll be explain that what is the difference in our next generation. So a computer could only understand the machine language, which a human being could not understand. So and that is where the issue of programming came in. That is putting what a human language into a machine language. That is where programming came in. And we are saying that they could only solve one problem at a time. And I think we discussed that. So they were not able to solve several problems simultaneously. So it could only solve one. Once it ends, that's when it could solve another problem. So it took long. And you can see they were inefficient. To input the instructions into the computer, one used a punched card or a paper tape. And then for the computer to output to the human being or to the user, it displayed it on printouts, only that. So punched cards for input and printouts for output. And therefore, we can say the two notable machines of the first generation were the ENIAC and the UNIVAC. And from what we described when we are looking at the history, you can see they fit in very well in what we are describing as the first generation computers. Looking at the second generation computers, now the second generation computers, we add transistors. Now, transistors replaced vacuum tubes for circuitry. And one transistor replaced an equivalent of 40 vacuum tubes. So that means you eliminate 40 vacuum tubes, one transistor, another 40, one transistor. So you can see that also reduced the size, because where 40 vacuum tubes could fit, one transistor was used. So this allowed computers to become smaller. It also allowed computers to be faster, to be cheaper, to be more energy efficient and more reliable. But still, they generated a great deal of heat, and that also damaged the computer. Can I request for a break of 5 minutes?
Okay.
Yeah. Okay.
Hello.
Hello.
I could not hear you.
She asked for a break.
I asked for a break.
It's okay.
Yeah, to take water. When you are talking alone, you feel thirsty. So I'm gulping a glass of water, then we continue. 1 minute and I'm back.
Okay, it's fine.
I think we can continue. We can continue. You can still see my screen?
Yes.
Okay, perfect. Okay, still continue with the second generation computers. Now, in the second generation, computers moved from the binary machine language to what we call symbolic assembly language, or which is more of a human language. And this allowed programmers to specify instructions in words. So this is what I was talking about when I was talking about machine language, is whereby a machine could only understand its language, but you as a human being, you could not. But now in the second generation, it was possible for a user or for a programmer to specify instruction using the natural language we talk, we know of. So that was a very major improvement, and that's what we call symbolic or assembly language. Also, second generation computers used punched cards like the first generation. and for input, and printouts the same for output. So that part did not change or did not improve. They still relied on punched cards and printouts. This is the first time computers could store instructions in their memory. And their memory came now, they moved from using magnetic drums to magnetic core technology. So initially they were using magnetic drums, but this time now, in the second generation, magnetic core technology now came into use. Now moving on to the third generation, and in the third generation, there was a development of integrated circuits. And we say integrated circuit actually is the hallmark or the what defines third generation computers. And integrated circuits were basically transistors, which were used in the second generation. So these transistors were small in size, what we call miniaturized, and they were placed on silicon chips. So when they were placed on the silicon chips, they were called semiconductors. And that now is what we call an integrated circuit. With using transistors, it increased speed and efficiency of computers. So the failure rate or the malfunctioning rate reduced. So they became more faster and efficient. Computers continue to be much smaller and cheaper compared to the second generation of computers. So they were smaller and cheaper. In addition, they could carry out very many instructions within a very short period of time. So we say it carried out instructions in billions within a second. Also in third generation computers ushered in the use of computers, not computers but keyboards. So computers could use keyboards as for input, and they could use monitors for output. So remember the first and the second, we talked about input was by punched cards. Here we are seeing that being replaced by keyboard. We talked about output by printouts. Here we are seeing that being replaced by monitors. So it was in the third generation where computers could use keyboards and monitors. And these allowed the use of operating system allowed the computer to run many applications at one time, because all that could be monitored from the main memory. And it is still in the third generation where computers for the first time became accessible to the mass audience or to the general public, because they were cheaper and they were smaller than the first and the second generation. Moving on to the fourth generation, somebody to mute. Somebody has to mute. Moving on to the fourth generation, and in the fourth generation, the microprocessor defines the fourth generation. And the microprocessor now replaced the integrated circuits of the third generation. A microprocessor is actually thousands of integrated circuits which are built into a single silicon chip. So those thousands of ICs, when they are put in a single silicon chip, then now that becomes a microprocessor, and that is what was used in the fourth generations. And here in the fourth generation, computers continued becoming smaller, they continued becoming more powerful, and it is in the fourth generation when computers could be linked or could be connected together to form network. And that is, this ability to be linked which eventually led to the development of the internet. So that came into being in the fourth generation. Also, fourth generation computers, they saw the development of graphical user interfaces, the use of the mouse, and other handheld devices. So it was in the fourth generation whereby mouse, graphical user interfaces, and other handheld devices could now be connected or could be used in a computer. The last generation is the fifth generation, and the fifth generation is based on artificial intelligence. What we mean by that is that fifth generation, now computers started acting with an intellect, with an artificial intellect, which already, what we mean by artificial is that that intellect has already been programmed by a human being. So the artificial intelligence means that the computers were able now to think, to act like human beings, but artificially, using an intellect which is artificial, or of course programmed and input there by a human being. These computers are still in development. It is what we have today, and they are still in development. So the 5th generation is where we are today. So we have not yet moved to the 6th generation. We are still in the 5th generation. It is still under development. It is in the 5th generation where parallel processing was possible. What we mean by parallel processing is whereby you are able to run several processes at the same time. For instance, I know you using your computer or using your phone, you can be searching. When you're searching from a search engine, and you are searching from different sites at the same time, you open multiple tabs and they are all searching. That is parallel. That action, what is happening is that it is being processed parallel. You can be typing on your computer while you can connect and your kid is also playing, or you can also be listening to music from the same computer. You see, what that is happening is that there are processes which are happening, but they are happening at the same time. So that's what we call parallel process. For instance, I'm teaching, so I'm projecting my slides, but at the same time, I'm using this computer to record and also for you to teach. So there are many processes happening at the same time, and that is what that ability of a computer is what is helping computer to artificially be able to think or act like a human being. So the goal of a 5th generation is to develop devices that respond to natural language. And you can bear witness that it is possible nowadays to use natural language. For instance, Google search engine, it has the ability for you to speak to the search engine what you want to search. Instead of typing, you click the microphone icon and then you speak what you want to search, and it searches, provided you pronounce the words the way they are supposed to be pronounced, not with our the problem we usually have with our mother tongue interference. So it is possible to search, and also that is the same technology or ability Safaricom are using. You see, my voice, my password, you speak a word, and our phones are computers, they are able to recognize that. So that device is able to respond to natural language. And also that's our next point there, where we are saying that there are some applications such as voice recognition that are being used today. That is one of the developments, another development in the 5th generation. So you see that in the 5th generation, now computers, what we are using today, the phones, the computers, the ATMs, the tablets, whatever, they are in the 5th generation, and they are able to do what we have talked about. So that is how we group the development of computers into the 5 generations. Here I'm showing you the further reading. One is a YouTube, so you listen, and the others they are all online, so they are hyperlinked. You need just to click and they open and you read, just to make yourself understand better, clarify areas which maybe were not clear, and also to build up your knowledge on the history of the personal computer. So that marks the end of our first topic. Any question before I move to the second? I want to introduce the second topic. Any question? I think there's no question, so I move to the second topic. Now, the second, are you there?
Yes, we are here.
You can see my new slides?
Yes.
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 Let's continue. Yeah, perfect. It's good to confirm. You might find you are talking to yourself. Okay, so now we get to specifically, the second topic is about introduction to computers. And computer is made up of two parts, what we call the hardware and the software. Hardware is the tangible part of a computer system, which you can see, which you can touch. So that is what we call the hardware. And this is a diagrammatic representation of what I can term to be how the hardware is organized. It has an input device. So the input device can be a keyboard. It has an output device, that is the monitor. It has a motherboard. Actually, that is the brain, where all in terms of systems, this is where most of the processing, most of the functions, the soft part of the computer happens in here, in the motherboard. It houses everything. It houses the CPU, or the central processing unit. It houses the memory. It houses the hard drives. So all those are housed, or they are found in the motherboard. So this is also another diagrammatic representation of the hardware. That is it also includes speakers, also being output devices, microphone. Microphone is an input device. The mouse, and mouse is also an input device because it instructs. It sends instructions on what to do. When you click, you meant to click, so you are instructing the computer to open that or to do whatever you want to do. So you are doing that through a mouse. So it's also an input device. So this is a diagrammatic representation of the hardware bit of a computer. So this a basic hardware of a personal computer consists of the CPU, or that which I've explained. So I want to look at each in detail. We start with the central processing unit. We say the CPU, or the CPU is the brain of the computer. So the same way, the human body is a system, and it has a brain, where is what we can produce the CPU. So the CPU is where the thinking, the processing, the coordination, all that is done in the CPU. So we say it directs, it controls the entire computer system and performs all the arithmetic and logical operations that is done in the CPU. What about the memory? Now the memory is where the programs and the data are stored. Programs are like the list of instructions which are to be executed on our data. So those ones need to be stored somewhere. So where are they stored? They are stored in the memory unit. And in the memory unit, we have two types. We have the read-only memory and the random access memory. The read-only memory contains the pre-programmed computer instructions, such as what we call the BIOS, the basic input-output system. So when a computer is being manufactured, there are some basic instructions. Yes. Yes, go ahead. We are not hearing. Hello? Hello?
Now we are getting you clear.
Sorry? You are getting?
Someone is complaining that you are not clear, but we are getting you clear.
Yes, but somebody said she has a question. Can I continue?
Yes, just carry on.
Continue.
Yes. Continue.
Okay. So I was explaining these two types of memory, the read-only and the RAM, the ROM and the RAM. I was saying that when a computer is being manufactured, it is manufactured with some instructions on how the parts will communicate or will integrate. And that is what we call the read-only memory. So those instructions actually come from the manufacturer. And that is what we call the ROM. And they are already pre-programmed computer instruction, like how an example is when you connect the keyboard to a computer, it recognizes something has been attached to it. When you disconnect, it also you can see that it recognizes that something has disconnected. Even look at the experience with our phones. If you put the speakers, it is able to sense that a device has been attached to it or has been connected to it. Now, the ability to recognize such an instruction comes with the computer, with the shell of the computer. So that is not built what as we are going to see now in the RAM. That is already there, and is what we call the ROM, the pre-programmed computer instructions. Now the other memory, which is now the RAM, is now used to store programs and data which you are running actually temporarily. For instance, now I open a document. That document I'm seeing is stored in the RAM. So it only stores the data and programs, but ROM stores instructions on how the computer is going to function. So that is the difference. Then RAM, one thing, RAM is is temporary. So it is only there when the computer is powered on, but the ROM is permanent. It is permanent. So once you switch off your computer, you will not be able to see you are closed. Actually, you will have closed the program or the software you're working with or the application and even the data you are working on. Because when you are working on it, it was in the RAM. And that is what we call the temporary storage. So those are the two types of storage in the memory unit. These are like how it can be viewed diagrammatically and how it works. Now, the other part is the input devices, and the input devices translate data from what human beings understand to what a computer can work with. So, I want to click. I understand to click, but a computer will understand something else. So what translates what a human beings want to do to what a computer can work with is an input device. So we have input devices like keyboard, mouse, joystick, microphone, all that, even scanners. Those are input devices. So basically the work of an input device is to translate data from the form humans understand to the form that a computer can work with. In terms of input devices, we have keyboards. Keyboards, they have really developed, and we have various types. We have the traditional. This is one of the traditional keyboards. At least I'm aged enough to have used it. If you compare the traditional keyboard, actually the keys were separate. the alphabetical keys were separate, the numerical keys were separate, the function keys were separate. And you can see it was actually separated. So that is what we call the traditional keyboard. We have the flexible keyboards, keyboards which you can roll, you can fold and put it in your handbag, and whenever you get to where you want, you fix it. That is a flexible keyboard. We have the ergonomic keyboards. These are keyboards with somewhere to place your palms. These are, I saw it in a museum, in an ICT museum. I've not seen it in the market, but these are keyboards which allows you to remember, but this one will cover it in the challenges of health with ICT. Prolonged use of the keyboard can bring, and you being health practitioners, you know that it can bring problems with your the ankles on the fingers, the joints in your hands. So there was an invention of the ergonomic keyboard which allows you to place your fingers in the right way. Then we have the wireless keyboards. These are actually these are the new entrant in the market, whereby the same way we have wireless mouse. We have a wireless keyboard. It is not attached to the computer, but you only need that gadget, the Bluetooth, the Bluetooth. You put it on the computer and you're able to communicate and you're able to type. The PDA the keyboards, the ones which had this one. Remember these types of phones, and even nowadays we have some. That kind of a keyboard is called the PDA, or the personal digital assistant keyboard. Then we have the ATM keyboards. You know, when you go to an ATM, that kind of where you input the details. And I'm not talking about the touch screen. I'm talking about the keyboard where you key in. That is also another type of keyboard. When we talk about the mouse as an input device, we have also types. We have the mechanical, and the mechanical one, for those, I know our class is in terms of demographics, we are mixed. You might have seen this kind of a mouse which had a ball, which had a rubber or a metal ball on the underside. And this ball is the one which was directing actually the mouse to where you want your instruction to be input. But nowadays, this one has already been overtaken by events. Nowadays, we have the optical mouse, and this one uses laser to detect the mouse movement. So this kind of mouse, actually, it has like a lighting. This kind of it lights. So that this laser is the one which recognizes the movements and also directs or controls the movements to where you want your instruction to be executed. We have other input devices like the trackball, the track point, the touch pad, and the touch screen. Where do we use that? The touch screen, you are aware that even our phones, the ATMs, the air conditioners, air controls in buildings you put and all that. The touchpad, we have like the biometric systems, all those are the other input devices. The track point, it is in a mouse, not in a mouse, sorry, in a keyboard, you'll find a red, like mine has. It has a red button or point. You can use that point to direct the cursor to where you want your instruction. So that is, we call it a track point. Then we have a trackball. A trackball is usually in a mouse. In a mouse, some mouse, they have a ball on top. So you can use you can scroll using instead of moving the mouse, you scroll using that roundish or that ball. So that ball moves the cursor to where you want. That is what we call a trackball. So all those are input devices. Still other input devices, we have the joystick. This is commonly used for computer games by our kids and the teenagers and all that. We have the light pens, and light pens, I've seen them being used. Maybe some phones have light pens. No, phones use a stylus. Light pens are used, I've seen them in banks to sign, to draw, and many other things. And they are very sensitive. Light sensitive, you point at a particular point and it recognizes that. Then we have stylus. Stylus is what I was talking about. Some phones come with a pen-like device or tablets. You use it, maybe you can sign, you can write, and all that. So all those are input devices. Then we have scanning devices as an input device. We have the optical scanners, the card readers, the barcode readers, and the character mark recognition devices. You know, like the optical scanners, like the scanner whereby we scan our documents. The card readers, the ones, the ATMs use that. When you go to some hotels and you are given a card with already input instructions and you just place the card on the door and it opens. That's a card reader. We have barcode readers. These are many. We like in hospitals, you find that every asset is barcoded. It has a barcode. You get even in pharmacy, you find that the drugs are barcoded, and each barcode represents it contains some details about that drug and all that. And for you now to be able to know, you as a human being, your eyes, you are not able to see, to decipher or to understand what those barcodes mean. And for them to make sense, you have to use a barcode reader, which you read the barcode to give you instructions. So that's a barcode reader. Character and mark recognition, this is used in checks. You know that when you take your check to the bank, they put it in a particular machine which reads it. So somebody has unmuted. Okay. So that is character and mark recognition used for checks. Image capturing. We have digital, the cameras, both digital and the video cameras. The output devices we have, this is now the opposite of input. The output devices now translate data or instructions from the computer into a form a human can understand. So that media used by the computer to display responses to a user request and instruction is what is called an output device. And all these include monitor, they include audio speakers, they include printers. So what are they doing? They are translating what is in the computer to a human, to what a human can understand, or they are displaying the requests over the user. So we have these types of computers, monitors, the cathode. Those were the long time ago. We have now the LCD or the liquid crystal, and even now we have the curved ones. The printers, you know, we have the impact and non-impact. Impact, just briefly, just the difference is that the impact printers, to print, the letter has to come into contact with the paper, and that is why they are called impact printers. So it prints by using pressure, striking the paper. And you find that these kind of printers, they make noise. Those printers make noise because of that impact. The non-impact printers are now the new thing. That is whereby you don't realize it is printing, you don't hear any noise. So what happens, there is no that coming together, that strike of the paper. So what happens is that they use either laser, or they use spray, or they or photography. So that technology of laser spraying or the photography or it is the one which transfers the characters with the ink to the paper. So you realize you not hear any noise. These are the grammatic representations of that. Then still under hardware, we have the storage devices and more so the secondary storage devices. And secondary storage devices are attached to the computer system. And basically they are used to store programs and data permanently for the purposes of retrieving them for future use. So our flash disks, that is our USBs, our phones also as a storage device, our hard disk, our CD-ROMs, those are secondary storage devices. And we use them to store programs and even to store data for future use. This is an example of a hard disk. And these ones are made of rigid materials, unlike floppy disks, and they hold a greater amount of data. You know, these ones are the optical disks. Other storage devices, we have now the USB flash drives and the solid state, the SDs, the solid state storage. And now, what we call the CPU. Remember, we were talking about, if you remember our diagrammatic representation of hardware. We have seen speakers as output keyboards, mouse, microphone, monitors. Now, what is this we are calling the system unit? It is composed of all this. It is composed of all this, what we are calling the system unit. It is the cover, the outside cover, the power supply, the motherboard, all that until the modem. And here I've explained the uses or what is meant for each. Like the cover is the outer shell, and its work is actually to protect the circuits. It cools the system. And also to organize, to put the whole thing together, to organize it is the work of the cover. The power supply, basically for powering every device, and the power supply contains all these. This is just for your information. So that, by the way, just for your information, it is also good to know about these things because we work with machines. Then we take our machines to our technician. Then you are told of a terminology which you think is so Greek, is something which you have never heard of. So it is good to be aware of these things so that you don't look like you don't know about what's happening. So these are power parts of our power supply, or these. Then the motherboard contains, when we are talking about the motherboard, it has the microprocessors, it has the BIOS, and this is how it looks like. Then still in the system unit, or it has what we call expansion slots, whereby other than what your computer has come with, you can buy additional memory. You can buy additional memory, and you want to add into your computer. So where do you add it? It has come with a slot where you can fix that. So it has slots for graphic cards. If your computer is not able to recognize graphics, you just buy that card and you put it in that slot. It has a sound card, modem cards, and what we call the NICs. This is for network. For instance, your computer you connect to the internet and it is not responding. It is not recognizing. So you take it to the technician and it tells you that we have to insert an NIC, or a network interface card. So once it is inserted, you see it is able to recognize network. So it means that your computer has an expansion slot which allows this card to be inserted. So that is all about the computer hardware bit. We are talking about introduction to computer, looking at the various parts of a computer, and started with the hardware, where we have seen diagrammatically how it looks like, and we have looked at each and every part of the computer hardware and its function. So I want to stop there. Next, we'll be looking at now the second part of a computer, which is now the software. Since we said a computer is composed of two parts, the hardware and the software. So we have covered the hardware. So next we are going to cover the software. And at this point, I want to welcome any clarifications because I wish to stop there. Any questions? Are you okay?
Yes.
Yes.
Thank you for confirming. Thank you for confirming. I expand on what?
Yes, that's fine.
Okay, so at this point, for this topic, the further reading I will be giving at the end of the main topic. Once we cover the software, I'll give you the further reading for this particular topic. Thank you so much. I'm happy to have met you, not physically, but virtually. I'm happy with the attendance. It's very impressive. You have logged in at the right time, and I'm very happy. I hope to see you next week at the same time. Stay safe. Goodbye.
Thank you. Bye.
Bye. Thank you. Bye.